With the increasing interest in alternative positioning systems to supplement GPS, Lab is continuing to develop applications of our hypersynchronized network, or HSN, in this space. For UAV navigation, our current test platform is a Taro hexcopter equipped with an HSN node and a GPS module collecting data to determine a post-process kinematic or PPK solution, which, with its centimeter level precision, is our positioning reference. In our current experimental setup, we have 9 static HSN nodes, each acting as beacons. For 3-dimensional positioning, a minimum of 3 beacon nodes are required. However, to improve the multilateration geometry, especially when the drone is close to the ground, we have added additional nodes, notably below the takeoff and landing point. HSN enables a member node to determine its position by listening to transmissions from synchronized neighbor nodes and relays this location data to any member of the network for real-time display, which is shown here using Google Earth. We're in the process of integrating HSN into the UAV navigation system. These recent test results indicate that HSN can deliver 5 cm accuracy 99% of the time when static and sub-meter accuracy when in flight. And so we are confident that HSN can provide a feasible alternative or backup to GPS. We are pursuing a target of decimeter level in-flight positioning, and we are planning to fuse our Doppler shift measurements and IMU corrections with our range estimations to reach this goal. We are also investigating band stitching to achieve high bandwidth ranging with our existing radio transceiver, as this offers a significant precision improvement. We look forward to demonstrating this system for you soon. Thank you for watching.